we're students at Greenline Tech in Holland, Michigan. Today we're going to be talking to you about alternators, what they are, how they work, common customer concerns, testing and diagnosis, and how to replace them. Alright, so first we're going to talk about what an alternator is. So as your engine converts combustion into rotational energy, it uses electricity to operate all of its supplementary systems, like fuel injection, ignition timing, and all the future comforts like radio, heated and cooled seats, and all the nice things that make it enjoyable to drive your car. So what an alternator does is it takes a little bit of that rotational energy and converts it back into electricity and recharges the battery and maintains a stable voltage.
Since the alternator is belt-driven, that means it's going to be on the front plane of the engine bay in line with all the other pulleys. And the pulley on the alternator is roughly a quarter size of the crankshaft, so that when the engine is running at operating speeds, the alternator will be spinning roughly 4 times that speed, so it can maintain the charge of your battery.
Alright, so now let's get into components of the alternator. So on the very outside you have your pulley, which is the smallest pulley on the vehicle, which is used to drive the internal assembly of the alternator. Then you have your casing, which like I said, has a lot of holes in it. It's very ventilated. This one's pretty light, sometimes they can be heavy. And then some alternators have an integrated fan, which is integrated onto the rotor assembly to help cool the alternator. Not all of them have it, but it's something you should be aware of. And then these are the most important parts of your alternator. You have your stator and your rotor assembly. And now these are 2 strong electromagnets. This one stays stationary, and this one is connected to your bearings and your pulley, and it rotates inside the stator assembly. This uses the principles of electromagnets to produce an electric current in the stator field windings, which is then sent to a rectifier bridge, which converts the AC current produced in the stator assembly into DC current, which your car can use. The other important piece of your alternator is your voltage regulator, which regulates the voltage output that goes across the slip rings and brushes into your rotor assembly. That changes the strength of the electromagnet in the rotor assembly, which in turn changes the amount of electrons that are passed into the stator field windings, which changes the amperage output of the alternator. When your car is idling, that's at about 700 RPM, which means the alternator is turning at about 2800 RPM, which is about the maximum output your alternator is going to produce. This gearing effect produced by the 2 pulleys allows the alternator to always be constantly charging the battery even if the engine's idling, because the amperage output tops off around there, and even if you're revving the engine to about 6,000 or 7,000 RPM, you're not going to be producing any more power realistically. But what that means is the voltage regulator can lower the voltage when the batteries doesn't need to be charged, so that there's a weaker magnet in the stator assembly, which produces less resistance when it's turned by the pulley, which produces less current output, so you're not frying your battery all the time.
Some customer concerns you will hear that will indicate a failing alternator is a battery light that comes on when they're driving. This indicates that their battery is significantly underpowered and is not giving enough voltage to maintain and run your car. This usually means that you'll have less than an hour to go on just the battery. It means that your alternator is not charging your battery and it will die soon. Another customer concern you'll hear is that they have erratic light or gauge operation. So for example, their headlights will either be dim or flickering. This could indicate a failing alternator. And another thing that could indicate that is their voltage gauge moving erratically, so whether that be moving up or down too much, this could all indicate that your alternator is failing. Alright, now we're going to move over to testing and diagnosis of an alternator. I would like to mention that you should always test your battery first to see if that's okay, because if your battery's not working properly or it's failing, then your alternator won't be working properly either. So the first test you're going to want to do on an alternator is with a test light. You're going to take the clip of the test light and connect it to the negative battery terminal. You're going to take the probe of the test light and come over to the alternator and touch it to the post that is connecting to the battery. If it lights up, you know you're getting power, so it's good.
So you can see the post and the battery down there that Alex is about to touch. When you touch it, it should always be hot. You should always have power coming from the battery to that post. So your test light should always light up when you touch it if it's grounded. Alright, so the next test you're going to do is voltage drop test using your standard DVOM or digital volt. What you want to ensure is that you don't have any higher than normal resistance in the cables running from your alternator to the battery or grounding the alternator on the case ground. Because an alternator is case grounded, meaning it gets its ground from its connection to the frame of the vehicle, any corrosion or rust buildup can affect the ground of the alternator and affect your electrical circuit. So what your voltage drop test does is ensure that you don't have any excessive resistance within that circuit. Alright, so here's how you run a voltage drop test. For ease of access, I already set everything up, and I'm using fused jumper leads just to make sure I don't have to hold the DVOM probes on each stud. So I have my positive jumper lead running from the positive terminal of the battery to the positive terminal, or the positive lead of the DVOM. The DVOM is set to DC voltage. You can see right now that it's zeroed out. It's reading 0 millivolts difference between the stud on the alternator and the battery. And then my negative lead from the DVOM is running to my negative jumper lead, which is running to that positive post on the back of the alternator. Alright, so now we're going to go around and start the vehicle. Looking at the voltage drop between the alternator on the positive post and the battery. As you can see, it's jumping around from 300 to 400 millivolts, which is within tolerance, because like I said, because you want to have about less than half a volt drop in your circuit. So with 300 millivolts is equal to 0.3 volts, you're really all right. There's a little bit of resistance, it's a little high, but it's not something you need to be concerned about. So then we're going to go. And that's at idle, so that's important taking a note. We're going to rev it a little bit to about 2,000 RPM. Because that's operating RPM for the alternator, that's about where it peaks out. So you can see that the voltage drop went down a little bit when we revved it, which is good. And now we're going to switch over to the ground side. Alright, so now we have it set up to measure the ground side of the circuit. You're going to be going from the negative terminal on the battery to your DVOM, and then from your DVOM to the case of the alternator. Because the alternator is case grounded, you want to measure the difference in grounding at the alternator to the most negative point on the circuit, which is your battery. So now we're going to go around and start the vehicle. Same thing as before, you want to get around a base reading, which is about 75 millivolts, so our ground is actually very good. And you want to do the same thing, and rev it to about 2,000 RPM. And you'll see that the reading stays about the same for that one, which is alright. 60 millivolts is an exceptionally good ground. Like I said, it's the same thing, you want less than half a volt, which that's 0.05 volts. So that's a very good ground, no concern there. You have a much higher resistance on the positive side of the battery, leading from your cables to the battery. So if you're going to address one of those concerns, I would address the battery side before you pull the alternator out and clean out your ground.
Alright, so the third test is going to be the amperage output test. For this, we'll be using the VAT40, and to test the alternator, you're going to connect it to the battery, and then you're going to take the amperage clamp and connect it to the cable that is going from the alternator to the battery. And you want to get it as close to the alternator as possible so you can accurately measure the amperage. And what this is going to do is test the amperage that the alternator is putting out to maintain the charge of the battery.
All right.
So now we're going to start the car and rev it to about 2,000 RPMs again. And from there, you'll use the VAT40 and apply a load to test the amperage.
see that when the voltage starts to drop off, this amperage increases to around 120 amps, which is really good for the alternator. Your alternator output on the VAT40 should be within 10% of the stamp spec on the alternator casing, or on ProDemand or some other service information utility. You'll be able to find the amperage specification for the stock alternator. I think this one is 135 amps. Actually this one's 120 amps. So that 120 amp reading is actually really, really good. Like I showed you, you want to load the battery until you start to drop below 12 volts. That's when the alternator is going to kick into high gear and start charging the battery with the full amperage that it can produce. You might not have access to a VAT40, so this might be a test you might have to take it to a shop to do.
Alright, so now we're going to go over how to remove and reinstall the alternator. On most cars, it'll be easy, like on this Malibu. You can see here, it's at the top of the engine bay. It's easy to get to. The bolts are right here, and on the other side, it's easy to remove. But some cars, it's not as easy. Like on this Saturn, you can see the alternator is tucked under, back behind the wheel well and under everything. It's a pain to get to, and some cars are designed like this, but it'll always be at the front of the engine.
I just want to quick run through some tools you're going to need to do this job. First off, you're going to need a serpentine belt tool, or some sort of ratcheting tool or wrench to remove the serpentine belt. Different tensioners have different applications. So this one has a block style where there's like 3/8 or half-inch drive blocks you stick into the tensioner. Some of them are just simply like hex designs, so you can use sockets or wrenches. Then we have a 3/8 ratchet set to pull the nuts off, a 3/8 torque wrench for when we put everything back together we can ensure proper torque, a wire brush to clean up any grounds you want to clean up, and a combination wrench set just because sometimes you need to use wrenches to get in tight spaces. The first thing you want to do is unplug your battery. We've already done that on this one. This is a side terminal one, so you need a small wrench or a side terminal tool. Just make sure both of your leads are unplugged and tucked away just so you don't accidentally short anything. Alright, so the next thing you're going to want to do is get your serpentine belt off the alternator. This car has an automatic tensioner. It's kind of difficult to see with Alex getting it, but there's a tensioner that's tensioning on the belt, which it's spring loaded, and you slip a belt tensioning tool in to push the belt and release tension so you can slip it off of the alternator pulley like so. Now if you release tensioning tool and remove it, our belt is free and we can remove the alternator. You also want to make sure you unplug the wires going into your alternator. These plugs are kind of hard to get at behind everything, so I'm going to quick unplug those. And there's a bolt and a nut holding on the stud to the back of the alternator that connects to the positive wire running to your battery. Again, it's kind of hard to see with me in the way, blocking the light, but there you go, you can kind of see it now. So you just want to remove that nut and unplug the connector going into the voltage regulator, and then we're going to start moving the nuts and pulling the alternator out. Alright, so Alex is working on getting the nut off the stud of the back of the alternator. Got that free. So let's unplug the voltage regulator cable. Just be careful with the plastic clips, you don't want to break anything. Next, with the wires free, you can crack the bolts loose. You don't want to remove the bolt, so just crack each bolt loose. This is a 2-bolt style connection. Some have 3, some have 2, some have 4. It really depends on the vehicle, so check your service manual. Don't rely on just what we're saying. After you crack each one loose, you can start removing both bolts. there's actually one more nut on the back of the alternator that we didn't notice before. It's holding it into a stud. So just make sure you visually check everything and can reference service information if you have access to it. Alright, and now with all of the nuts and bolts loose, you should be able to just wiggle the alternator out. Sometimes there's these in place, and you might need a pry bar to pry it out. This one came out pretty easy. And here's our alternator. One thing you can do now, if you notice there's a lot of corrosion buildup, is you can clean the mounting surfaces to the block. So you can clean this bolt hole and this bolt hole, and you can clean this stud up here because you can see there's some rust and corrosion buildup on the end of this stud. You can clean that up just because, like we said before, your alternator is case grounded to the block of the motor, so any corrosion buildup in here is going to affect your grounds. Alright, so now we're going to get back into reinstallation. So it can be kind of tricky to line the alternator bolts back up, especially with this one, because GM designed it so the long bolt in the back just runs into the firewall. You just kind of have to wiggle it around the same way you took it out and wiggle the bolts all into place. You want to make sure you get all the bolts lined up and the nuts lined up before you start torquing anything down, because if you start torquing stuff down and stuff's out of line, you're going to have to take everything back off to reline things back up.
Just won't slide in.
You push this end of the alternator back out.
Yo, can we use this for just 2 torques real quick?
Yeah, go for it.
We went back.
I'm just gonna like fast forward through it. So.
Can I use this clip?
2 torques. Alright, once you got the bolts lined up, you can plug back in your voltage regulator wiring and reconnect the terminal, the positive stud on the back of the battery with the nut you took off and cleaned. When you tighten down the nut on the back of the alternator, really just nice and tight, don't overdo it. It's really easy to overdo it and rip that post out of the back of the alternator. So just get it nice and snug. You don't have to go crazy. And that's plenty tight. Now we can tighten these bolts back down. Get the appropriate size socket. Start working them in. This is why it's important to get everything lined up properly first. You can see that that pivot bolt in the back allows the alternator to kind of drop and makes it very difficult to work in this front mount bolt. There we go. These are some really long bolts, so if you have access to an air ratchet or something like that, it can be nice to use that. So once you get the bolts snugged down, you can move on to the next one, because we're going to come back and hit this with a torque wrench to ensure proper torque. Alright, now that they're snugged up, we can move over to a torque wrench. We need to get the nut on the back to alternator. Never mind. Never mind, you can't see anything there. Alright, now that everything's snugged up, we're going to hit it with a torque wrench. The two bolts are 37 foot-pound, and that nut on the back is 25 foot-pound. So a torque wrench allows you to ensure exact torque and make sure you're not over-torquing and damaging anything, or under-torquing anything, and risking vibrations and loosening the bolts and backing them out, and destroying your alternator in the process. You can see that even with that back bolt snug, there's still a lot of way to go before you hit 37 foot-pound. These bolts are incredibly important because they ensure that the alternator is lined up on the belt plane and keep your serpentine belt from fraying or breaking after rubbing against the pulley.
on. Only in the 100. Roll over like crazy. Crank it one, PJ. Okay, what do you think? Yeah, okay. Is that good or bad? That's good. 128.
That last final click, and now we already have our wires run, so the last thing we need to do is get the serpentine belt back connected, re-plug in the battery, and you're all set. So we're going to use our serpentine belt tool, get it back in the tensioner, relieve tension, and then, oh no, run the belt back under the idler pulley. Sorry, you're not going to be able to see much during this. This is kind of a two-person job. So now that you have your serp belt run, you can release tension, verify that it is on. Here, can you verify that it's on all of the correct places? You can see here that it's riding up on the ribs here. So you want to release tension again, just a little bit this time, not all the way or it's going to flop off completely. Release a little bit of tension, line the belt back up on the ribs, and now tension it back up again. You can make sure that the belt's riding completely correctly on all the pulleys and you're not going to fray the belt and destroy it. Alright, now that everything's done, we can plug our battery back in and fire it up. After replacing an alternator, it's a good idea to generally run that alternator output test again and just make sure that your new alternator is performing to spec. Because we just reused our old alternator to demonstrate it to you guys, we're not going to do any of that just to save time and keep the video a little shorter than it's. Alright, thank you guys for watching. Hope you learned a little something about alternators. If you have any questions or concerns, you can leave a comment down below.